Welcome to this recap of surface area session video. Contents of this video are first a video explanation of surface area, then a worked example of surface area. There is an exam practice for functional skills Edexcel calculator paper level 2 featuring surface area, QR codes for surface area activities, and general resources to help with surface area, in particular nets. This video is how to work out surface area of a cuboid.
Surface area of a cuboid. To find the surface area of a cuboid with side lengths of 4 cm, 12 cm and 10 cm, we work out the area of each face and then add them up. This is the net of the cuboid. A cuboid has 6 faces. The area of the front face is 12 cm multiplied by 10 cm, which equals 120 cm. The area of the back face is 12 cm multiplied by 10 cm, which equals 120 cm. The area of the top face is 12 cm multiplied by 4 cm, which equals 48 cm. The area of the bottom face is 12 cm multiplied by 4 cm, which equals 48 cm. The area of the left side face is 10 cm multiplied by 4 cm, which equals 40 cm. The area of the right side face is 10 cm multiplied by 4 cm, which equals 40 cm. If you now add the area of each face together, you get a total surface area for the cuboid as 416 centimeters squared. However, instead of adding the surface area of each face separately, we can use the formula for the surface area of a cuboid. The formula for the surface area of a cuboid is where L equals length, W is the width, and H is the height. Example. The length of a cuboid is 12 centimeters, the width is 4 centimeters, and the height is 10 centimeters. What is the surface area of this cuboid? Using the formula, the surface area equals 2 multiplied by the length, 12 centimeters, multiplied by the width, 4 centimeters, plus the length, 12 centimeters, multiplied by the height, 10 centimeters, plus the height, 10 centimeters, multiplied by the width, 4 centimeters. Carrying out the calculation in the order of bit mass, we get the final answer for the surface area of this cuboid as 416 centimeters squared.
Okay, we will look at a worked example for surface area of a cuboid. So we're going to look at the question on the left. I've expanded it a bit on the right, but I will go through that. Find the surface area for the following cuboid. So we have got a 3D representation of a cuboid, which is a 3D rectangle with all the various measurements that you need. It's asking us to use the formula. Obviously, by all means, use the formula you're comfortable with. But also, as you saw from the video, you can work it out individually. What surface area definitely needs is to be really organised and clear in your workings. Also, you need to be pretty au fait with the terminology of height, length and width and how that is important. So surface area is area, so the units are meters squared. Be careful of mixed units. Like I said, usually does appear at level 2. There is a mixed unit there which we will convert to the units in the answer, so it's 0.9. So be a bit careful. We've got a decimal in there. Again, it just needs a bit of care, perhaps a bit of checking with the calculator. So with surface area, it is really important to be able to visualise a net. So again, a net is the shape unfolded. So when it's all folded up, it will form a 3D shape. A net can be used to make it clearer in a 2D format. At the end of the video, there's a couple of resources that might help you with nets and visualization. So I've drawn out a very close representation to what I think the net of this cuboid will be. It's not to scale, but I think it gives a good representation, and it's important to follow the steps. So this 8.5 meters here is the length. Okay, so be really clear. We need to be clear with our definitions. 8.5 length, and it's equivalent here. I've called the 3.2 height. So again, it's represented here. So that's the height, 3.2, length, 8.5, which is why I've labelled this square HL, which obviously is equivalent to H times L. The 0.9 is the width, and this features in these squares or rectangles here. So that's 0.9. So what I've done is I've labelled all of the rectangles with the dimensions I think they have, whether it's height, length or width. Obviously you can now see the calculations you have to do. So there is 1, 2, 3, 4, 5, 6. So you can do them individually, but it doesn't include 6 sums. Obviously the area, either height times length or length times width or height times width. So just be really careful each of the 6 times. Or as you realise, there are groups. So there's 2 sides exactly the same. So obviously you can treat those as the same, just times them by 2, which is really what this formula is doing and how I've expanded it here. So a length times width. So I have said, height times length. So here I've said it's 3.2 times 8.5, and there's 2 of them. Height times width, 3.2 times 0.9, and again there's 2 of them. Height, length and width, 8.5 times 0.9s, and there's 2 of them. 3 individual calculations, need to add them all up, comes to 75.46 centimetres squared. It is an area. Surface area has appeared in numerous forms and on numerous papers, so this is just a look at one of an example of using surface area.
The explanation for the questions in a functional skills level 2 maths reformed paper. The paper reference is as on the screen. Okay, so let's go and find question for this particular video. Okay, so question 8. James has a contract to paint 30 identical water tanks. He has to paint the outside surfaces of each tank, but not the top. Each surface is rectangular. You've got a 3D representation of the water tank with the measurements. The measurements are all in meters. It is not mixed units. James knows that 1 tin of paint is enough to cover 12 meters squared of surface. Costs £26.99, so that's referring to the tin of paint. Work out the total cost of the tins of paint he will need for all water tanks. Okay, so again, to put it into context, the subject content, so the underlying skills, is use formulas to find volumes and surface areas of 3D shapes. So again, it's really important to nail down what the question is asking you. So it's not a volume, we're not finding out the volume, we're finding out the surface area. Because James is painting the outside. He is not working out the capacity inside. For that we would need the volume. Okay, so a bit of
pre-knowledge that you need for surface area of a cuboid. So what we're looking at, if I bring that up, we're looking at how many faces there are. So a cuboid has 6 faces. So front, back, 2 sides and top, bottom. Obviously with this one, they're saying not the top. So we need 5 sides. Okay, just to make it a bit clearer, we're going to label the length. So the length is the longest side. The width, so the width in this occasion is here, and I will draw it. So that's an example of the width. We're going to call this height. Okay, so here is 0.60. Okay, so that is useful for when we sort of look and label the formula. Okay, so let's work it through it. So we know we have to have 5 sides. So we've got front and back. So they're 2 together. So front and back, if we call them, so those we need the front, we need the length and the height, and the back, because it's a rectangular cuboid, is exactly the same. So that would be 2 times length and width. So the measurements associated with the length and the height are 1.1 and 0.6. Okay, so we've done 2 of the 5. Next we have to do the 2 ends. So left, well that's right, that's left. So we've got 1 times left, 1 times right. So they're exactly the same, so we can group them together. So that would be 2 times width and height. So width there and then height, 1, 2. So the measurements associated with that is 0.8 times 0.6, and there are 2 of them. Okay, so we've got 1, 2, 3, 4 sides. 1 more side, which is the bottom, so not the top. So we've got 1 times bottom, and that is length and width. Okay. The measurement associated with that is 1.1 times 0.8. Okay, so there's all the measurements that you have to do, and then you need to add them all together. So I'm just going to clear the screen and bring something else across just to make it a bit clear. Okay, so I'll put all the measurements that we dealt with at the top half here, and obviously the instructions are to work through the sums there and then add them together. So add them together, you get 3.16. So the question asks us for 30 of them. So 3.16 times 30 equals 94.8 meters squared. Meters squared in there as well. Okay, so we worked out the surface area, and the question then goes on. James knows that 1 tin of paint is enough to cover 12 meters squared of surface, costs £26.99. So we've worked out the surface area. 1 tin covers 12 meters. So if we do 94.8 meters squared divided by 12, we should have how many tins? So if you did that on a calculator, you'd get 7.9, and that refers to 7.9 tins. But you can't go to the shop and ask for 7.9 tins. You have to go and ask for 8. So 8 is the answer for the tins. So 8 tins we know. We now know that they are £26.99. We need to work out the total cost. So 8 times £26.99, the total cost will be £215.92. Final bit of the video is concerned with resources and activities. One of them is a QR code. So again, I'll leave the instructions for the Apple products on the screen if you want to use that to how to work the QR code. That's just for a few seconds, then I'll scroll down to the Android version. Make that a bit bigger, a bit clearer. When I've done that, I will transfer over to the QR code. So if you want to do the activity, by all means. Okay, so it's an activity for surface area. Then the next couple of icons will be about just websites that I think would be useful and just a definition of them. So there's the website address, and that part, if you search for nets of 3D shapes, gives you quite a visual way of doing it, opening and flattening them so you can see the nets and what it turns into. And a bit of practicality, so template maker just shows it's all crafts that you can make with surface area templates. And again, an idea of how they all work now. Crafts, maybe some work activities. Again, the knowledge will lead to a better understanding of things.